おはようございます。
Good morning, ladies and gentlemen. My name is Hamaguchi, responsible for communications. Thank you for joining us today. Thank you for joining us at the Nissan Intelligent Factory tour and press session. Thank you for coming all the way to the Tochigi Plant. We appreciate your attendance. The state of emergency has now been lifted, and we're now able to host Nissan Intelligent Factory tour. We wanted to show you Tochigi Plant, which has evolved in the context of Nissan Intelligent Factory. At last, this day has come. Now, actually, we had scheduled this session at a much earlier date. That was the original intent and hope. However, because of the spread of COVID-19 infection, we've had to postpone the session on several different occasions in the past, which was inevitable. So that being the case, we're so happy that we're able to implement this program at last today. We are most pleased that we're able to at last host this event. But having said this, we have to continue to be vigilant when it comes to COVID-19 countermeasures. So we're taking full measures for COVID-19 countermeasures, but we appreciate your kind understanding and cooperation in the implementation of this COVID-19 countermeasures. And also last night, in the metropolitan area, we had a major earthquake. But we've carried out inspection within our plant facility, and we've found no problems in the context of earthquake. So please feel rest assured in your plant tour. There are no problems pertaining to the plant in the face of the earthquake. So I would like to introduce the participants for today. And we have with us Mr. Sakamoto, Executive Officer and Executive Vice President responsible for manufacturing and CM. And also we have with us Mr. Hirata, CVP, responsible for Vehicle Production Engineering and Development Division. We also have with us Plant Manager of this plant, Tochigi Plant, Mr. Kikuchi. So these are the three members who will be taking part in this program today. So the three members that we introduced today, the presentation will be available after the presentations are. Correction, we'll be taking Q&A after all the three presentations are over. So without further ado, I'd like to invite Mr. Sakamoto, the EVP, to carry out his presentation. Mr. Sakamoto, the floor is yours.
Once again, ladies and gentlemen, good morning. I am Sakamoto. Thank you for coming all the way to the Tochigi plant of Nissan Motor Company Limited. On behalf of the company, I would like to extend warm welcome to all of you. And this Nissan Intelligent Factory, which we are announcing today, 2 years ago, at the Nissan's global headquarters, I provided you with the concept and the component technologies for this Nissan Intelligent Factory. And since then, as Hamaguchi-san said earlier, we wanted to show you the shop floor in person as soon as possible to show you how we are going to build the cars of the next generation and ask for your feedback, but we had to put it off for several times because of the declaration of state of emergency. So we are very happy to welcome you today. I was looking forward to this day. Thank you very much for coming. Okay, let me start my presentation. I will briefly talk about the context or the background behind this Nissan Intelligent Factory concept. We have been exploring how the auto industry should be in the next generation, or how we should be manufacturing the cars in the future. There are 4 missions here. One is to break away from the conventional labor-intensive model. Traditional Ford start the mass production for T, and people were gathered to build cars in an efficient manner. And this was the first time that Ford introduced this mass production. This was epoch-making indeed. Having said that, we have been automating a lot of processes, but today, even today, we have been maintaining the same kind of production scheme practically. However, lately, around the world, not only Japan, but also in the rest of the regions, the number who are willing to work for car manufacturing is becoming less. And if you think about the pandemic, it's very difficult to gather a lot of people to build cars. So the first mission is to break away from this conventional scheme and establish a rational production scheme. And the second one is, needless to say, it's really difficult to introduce a labor-intensive model, and there's an aging and low childbirth society which we are facing. Therefore, unlike the old times, we cannot involve young people and develop their skills and assign them to the car building, which requires higher skills. This is becoming a challenge. That's the second one. And the third one, responding to the unforeseen with flexibility. Here again, one is pandemic and the supply issue of the parts, semiconductors, logistics disruptions. These are the challenges that we need to adapt to in order to continue our production. And these disruptions are resulting in this continuity. So how to address this is the question. And the last one, this is another important global challenge, which is CO2 emission or carbon neutrality. Fighting climate change. This is the area where we need to contribute to. These are after we satisfy these four conditions. Next page, please. We need to build our car production scheme for the next generation, which is adapted to the future. Electrification, vehicle intelligence, and connectivity. Building cars is growing more complex and advanced. We are writing a lot of software all at the same time, doing a calibration of different sensors and self-diagnosis, fail-safe system. These are the assurance that we are doing. So car building is becoming even more complex and challenging. If you look at battery, big battery with long autonomy and standard battery and vehicle intelligence and hands-off sophisticated autonomous driving technologies or standard driver assist technology like ADAS. There are different combinations of variations which are required to build cars. So in order to build more advanced and complex vehicles, we need to make the production scheme and production engineering more flexible. And this will be the key success factor for Nissan in the future. That is why we have been creating this Nissan Intelligent Factory. These are the four pillars. Today, I will show you around the shop floor to provide you with the details. Next page, please. In the introduction, carbon neutrality initiatives, what I would like to touch upon, which I had less opportunities to talk about in the past. And then we'll talk about the technological elements of Nissan Intelligent Factory, and Kikuchi-san will talk about the overview of the plant itself. Next page, please. Carbon neutrality. Next page, please. Well, this is self-explanatory. Around the world, we are seeing global trends related to climate change. Many agreements and declarations are made. Japanese government too declared to hit the carbon neutrality by 2050. And a lot of countermeasures are taken towards the goal. And we Nissan Motor declared to achieve carbon neutrality across company operations lifecycle of products by 2015 and electrify 100% of all new vehicle offerings in early 2030s in key markets and promote electrification innovation in production technologies to attain carbon neutrality even in the process of car building. Having said that, carbon neutrality initiatives is nothing new for us. We have been working on Nissan Green program to reduce the CO2 emission ahead of many people. In this Nissan Green program in 2010, more than 10 years ago, with the first generation mass-produced Nissan Leaf EV, the main market in the main category or main segment of the market, C segment hatchback mass-produced EV was introduced and offered EV where you can use every day. I was in charge of the engineering at the time as a division general manager. Then we came up with e-Power. This is about providing electric driving to help penetrate the electrification in the market. That was why we introduced e-Power. And at the time, I was ahead of the engineering and was fully involved in the development of this piece of technology. And in order to build these electrified vehicles, by minimizing the consumption of energy, we minimize the CO2 emission. That's what we have been doing. And going forward, we are going to promote innovations to do more on this front. Nissan Green Program. This is about the CO2 emissions in manufacturing operation. How much have we reduced the CO2 emission? For long years, we have been working on this. This started from 2005 to 2019. In order to build one car, we reduced 30% of the CO2 emission. This is already a track record. This is a result. And as of today, 70% of energy consumed is electricity, gas, fuel. Fuel is the light oil, and this accounts for 30%, which is 29% to be precise. And we are going to nullify this consumption at the end of the day, and that's the mission of the manufacturing team. Here you see how are we going to promote initiatives up till 2050, and this is a roadmap that we created. In 2019, as of today, which is approximately today, at the plant we have electricity at the plant. We use a compressor and using a high pressure air, which is a blue line, and we provide a high pressure air to the plant. And the gas, we use a boiler to evaporate it into a steam. And this is how we operate the plant. In 2030, what will happen? We will largely reduce the energy consumption. And on top of this pink one right here, within the campus, green energy, carbon neutral power generation, where we plan to use the fuel cell. We would like to generate power with fuel cell and use green energy, photovoltaic power generation, and windmills. We will combine the renewable energies and expand the scope of the trial. Between 2030 and 2050, the basic production process or production equipment should be electrified, and the source of the energy will be shifted to renewable energy and clean energy power generation. That's our aim. Next page, please. This is a specific example. It's pretty complex because the steel furnace, we do the casting. In this casting process, we use cokes in the furnace. We have to melt the steel and provide the nitrogen, carbon. So we need to electrify this furnace with the high frequency furnace. We need some technical development for this to happen, and the tools will be fully electrified. Today we are driving the tools with air, and aluminum melting ladle heater will be electrified fully. These are the technological developments that are necessary. Earlier, I talked about how to electrify these equipment. As you can see at the top, this is we shouldn't fully rely on the external clean energy. So within the campus, we would like to generate the clean energy. To be specific, bioethanol will be used and use the fuel cell battery SOFC, which is a carbon neutral power generation. And at this Tochigi, we are going to do the trial, and at the end of the day, we will deploy it across the globe. And as of today, in UK Sunderland plant, here We use wind power and solar power to generate a lot of electricity. And the other day, as we announced, microgrid is created and clean energy will be applied to a wide area. This is a specific numerical objectives of the concept. When 2030, 40% of the energy which is required to build cars will be reduced. And in the pink, we have some pink here, pink color here. This is the carbon neutral power generation which is done within the campus, and this is the impact of the trial. And this carbon neutral power generation and green energy procurement from the outside, and all the fully electrified energy will be used in 2050. And we will be fully carbon neutral. That's our intent. Based on this detailed roadmap, R&D, production engineering team are working on this to make it a reality. Moving on to the next one. That was all from me. I touched upon the carbon neutrality initiatives. Next is about Nissan Intelligent Factory system components and the new technologies that are used. And the CVP Hirata-san, in charge of this engineering, will be speaking. Thank you for your attention. Good morning, ladies and gentlemen. I'm in charge of the vehicle production engineering. My name is Hirata. Nice to meet you. Let me take this opportunity to talk about how to build cars for the next generation with Nissan Intelligent Factory and show you how the cars will change over time. Oh, sorry, excuse me. Let me take off my mask. And how the production line will be updated with new technologies. I will specifically show you the photos of the equipment which is used in this Nissan Intelligent Factory. In 2019, on the 28th of November, Nissan Intelligent Factory Tochigi is used as a pilot, and we are going to deploy it towards the globe, and that's what we announced. And this Nissan Intelligent Factory in Tochigi will be producing the next generation battery EV, which is Nissan Ariya. Nissan Ariya is equipped with a styling representing the first Nissan Intelligent Mobility touchpoint signaling, a redefinition of Nissan's design philosophy, 4 powertrain configuration to meet a wide range of customer needs, and ride comfort and handling without compromise with the new generation EV powertrain, as well as the latest driver assistance technologies and advanced connectivity. Nissan EVs have been undergoing evolution starting from Nissan Leaf that was introduced in 2010. Nissan Leaf during the model life have been updated, and today we have a range up to 458 kilometers. With the all-new Ariya next generation crossover EV Ariya, this is the first crossover EV at Nissan, and the range is up to 610 kilometers. And on top of this, it's more intelligent and more electrified. The number of ECU, which is an electrical control unit, this is double the number of first generation Nissan Leaf, and the number of signals is 2.5 times. And 2 types of battery have an output, and the energy weight ratio is 1.5 times, so it's largely updated from the Nissan Leaf. Now, let me talk about the 4 pillars of Nissan Intelligent Factory from the 3 perspectives by providing the specific examples of technology. One is Nissan's DNA in the all-new Ariya. This is Nissan's DNA in the all-new Ariya. We newly developed a platform for EV, and thanks to the platform, we have outstanding quietness and lounge-like interior, and stylish and low center of gravity with high visibility, which are very functional. And 4 types of powertrain, a wide color variation, and highly intelligent electric control unit are the representative examples of Nissan's DNA in Ariya. Now, in order to make this a reality, what kind of production technology did we use? One is SUMO, the simultaneous underfloor mounting operation. With one equipment, we can build a multiple powertrain components in the batch mounted from one single pallet. Today, we have several processes with labor-intensive work. As you can see, the operators have to work in such a hard position. And we fully automate this universal mounting in a single process. On the bottom left, we divided the pallets to front, center, and rear. And we have a common base, which is a two-layer structure. So ICE, e-Power, and EVs can be produced according to the combinations of the pallets. So this allows 27 different module combinations, which is very versatile. As I said, the all-new Ariya have 4 units, and with these 4 units, we are combine the right pallets for each powertrain. So with one single equipment, we can do the mounting. And the real-time vehicle position measurement enables a highly accurate component position correction. With this big and heavy powertrain unit is mounted in a single process, and we call it SUMO, simultaneous underfloor mounting operation. Next one is the automated tightening and alignment of suspension links. Here again, it used to be consisting of the several processes with manual operation, which was high workload. It was a complex and required high skills. But here again, we introduce a single process with automated alignment adjustment. High load work requiring high torque tightening has been fully automated. An adjustment by robot with an accuracy of 0.1 degree ensures alignment that exceeds the Takumi Master Craftsman precision. As a result, driving comfort and the stability are ensured on the EVs that we produce. Next one is automation of headliner installation. Headliner is the components on the ceiling of the car. And in the past, operators should come into the cabin to install the headliner, so it was very hard to do this. And with the vehicle intelligence and connectivity device, which are added to this device, the weight increased by 4 kilograms from the traditional car. And this installation is fully automated by robots. And this component is not tightened with bolt. We insert a clip instead. Today, the operators have to see that the clips are inserted fully using their fingers to feel it. But we actually added a sensor on the robot so that on the real-time basis, we can monitor the status. And once the clip is inserted fully, the work is complete. Next one is the automated cockpit module installation. Here again, we used to have 2 Takumi operators controlling the variations and left and right differences in this installation process. In the traditional process, we reproduce these high skills of Takumi master craftsmanship in robots. High-speed vision system precisely measures dimensions, calculates the optimal center point in real time, and assembles the CPM for a well-proportioned and seamless cockpit. Next one is the new dimple welding method. All new Ariya use an aluminum-made door. In the traditional aluminum door, the door sash, requires a spot welding like a steel door. However, the area of the electrode should be added on the panel to make this happen. But by applying this new dimple, which is a thin dimple, which is stamped, the electrodes, we can make the electrode size smaller. As a result, we can reduce the front pillar width by 5 millimeters and increase the visibility for the driver. Next one is electrical systems responding to increasing vehicle intelligence. As Sakamoto-san mentioned earlier today, depending on the specifications of the cars, we write the software at the plant for the ECU. The number of units largely increased from the traditional car in all new Ariya, and the volume of the data to be written in new Ariya is much larger than the traditional car. In order to respond to this, we introduced a communication speed of which is 20 times faster. And today you do the communication with the wire system, but now we are applying the wireless device instead. Next one is the core of EV, which is the motor production process. In the traditional EV and e-power motor, we use rare earth materials, a permanent magnet inserted in the rotor. But with the all-new Ariya, this is the first of the mass production vehicle where we use an 8-pole wound field synchronous motor. This wound field motor mass production. To mass produce this wound field motor, high speed and high precision and high density winding technology will be required. Like a needle of the injection, there is a 1.2 millimeters and 350 meter coil. One is wound by 128 per pole for a total of 944 times per 8 poles in 20 minutes. That's the equipment that we introduced. Next one is automated paint inspection. Today, in the paint shop, we detect the foreign objects on the surface with eyes of human beings. But by using the image processing equipment, in addition to the foreign objects that we identify, we also identify 6 other faults which were unseen with the human eyes. As you can see on the bottom left, LED light slit is reflected on the surface of the vehicle, and by shifting this light shift, we see the undulations of the light. We see the differences of the brightness of the light. So we can see the undulations or unevenness on the surface to identify any faults which were unseen in the human eyes. Compared with the traditional scheme, we can detect the foreign objects of the size of 0.3 millimeters, which is the most precise in the industry. And this findings of the inspection is stored at the centralized control center, and the operators can find this fault using this wearable where he can see this data on. Next one is about the integrated automated inspection system. Just like the paint shop today, we rely on human beings to assure quality, and operators need to keep concentration, and to this end, we rotate them in different positions so that they can keep their concentration. Just like the paint shop, we introduced the same image processing technology to inspect the complex specifications and detect minute flaws. For Europe, North America, and Japan, depending on the destinations, there are differences in specifications. So 56 items are inspected in full automation. Next one is about the initiatives or contribution to carbon neutrality. Starting with the world's first integrated painting and baking of bodies and bumpers. Traditionally, we baked and painted bumper and body separately because they use different materials and we apply different temperature. And we jointly developed the world's finest water-based paint coating, which can cure at low temperature. As a result, we can paint and bake the bodies and bumpers at the same time. So we used to bake body at 140 degrees Celsius, but now we can bake at 85 degrees Celsius, like the bumper. And as a result, we have the world's finest water-based paint coating and reduce the energy consumption by 25%, which is another big contribution in terms of energy saving. And because we are painting and baking the bodies and bumpers, we improve the quality but with a better color matching. And next is dry paint booth. Traditionally, we extracted the paint paste. We call it paint mist or paint waste. By using water, we collected this paint waste. So the humidity in the paint booth increased, and we were unable to efficiently circulate the air within this paint booth, and we had to discard this paint waste that we collected. By using dry powder, we collect the paint mist, and without increasing the humidity within the paint booth, we can recycle the air in the paint booth efficiently. And this paint waste is put into a block, and we are reusing it or try to reuse it eventually. And power generation with alternative fuel. This was already explained by Sakamoto-san. We are utilizing electricity generated by on-site fuel cells. From the latter half of 2022, we will do the field test of this fuel cell, and in 2030, we would like to fully apply it. And to this end, we are developing the technology. Next one is about the digitalization of the manufacturing. Starting with the quality assurance by establishing quality gates, automatic inspection in the paint booth. Besides this, we have quality assurance systems in other processes. We use the same network and the same platform to centralize the control so that we can automatically take record of the inspection and ensure traceability or increase the traceability. Next is the intelligent operations support system. By using MR technology, we provide a good training to the operators. We used to use textbooks and video and let them do the on-the-job training. But when it comes to complex process and the long one, it takes time to learn the skills. But we are using MR goggle, and we apply a hologram. And by using text and the manuals, we provide caution points and what to do. So by being there at the line operation, we can develop and train the operators. As a result, we can largely reduce the lead time to train skilled workers. Next is the remote equipment maintenance using IoT network. The data and the materials to fix the equipment is secured in the central control center where skilled maintenance workers are stationed. These veteran experienced expert is connected to the operators in the line operation in a network. So when the equipment breaks down, this expert provides hints and the best way to fix it so that we can reduce the lead time by which we restore the equipment. And the last page. This is how, in addition to shorter recovery time, we are applying predictive and preventive equipment maintenance before the failure happens. Continuous by applying the condition-based maintenance diagnostic technology, we apply the logic and thresholds automatically and prevent a failure. And thanks to IT, we are monitoring the equipment at all times, and by using AI, we identify the sign of faults or failure and minimize the production loss. These are many examples of the technology, and some of them will be shown to you during the plant tour later. That concludes my presentation. Thank you for your kind attention. Let me switch to Kikuchi in charge of the Tochigi plant. He will talk about the overview of this plant. Thank you for your attention. Hello, ladies and gentlemen. I am Kikuchi, plant manager of Tochigi Plant. Let me talk about the overview of this plant. Next page, please. Our plant is located at the center of Kaminokawa town. 4 kilometers is the width of this land. And around this campus, we have Kinugawa and Tagawa rivers. And as you can see, the campus is surrounded by greenery. This is where we are located. Next page, please. Here you see the layout of this plant. One of the characteristics is as follows. Casting, axle, and body shops are in this integrated production plant. And in the radius, we have 6.5 kilometers long proving ground, which is pretty long as a proving ground. The total area is 2.93 million square meters, which is approximately 60 times of Tokyo Dome. And we have 5,200 people working here. And this blue one, NIF, Nissan Intelligent Factory, is where you are going to visit today after this presentation. Next page, please. As we run our operation, we value coexistence with the local communities. Around this plant, there are a lot of greeneries and there are a lot of biodiversity, and we are protecting the ecosystems around our campus. And in this, especially, we are putting a lot of efforts on quality of water, controlling the quality of water. In Nissan Intelligent Factory, as Hirata-san mentioned earlier, new paint shop does not require water. In other words, there's no water wastewater. And other industrial waste, which may be emitted from the rest of the processes, are cleaned before it goes out. And we are monitoring this waste 24 hours around the clock. By using this processed water, we have a river created within this campus. This fiscal year, on the 1st of April, my first job was to put the fireflies in this river. This summer, these fireflies grew up and they were illuminating at night. Unfortunately, today you cannot see it. But this is one of the initiatives to enhance the quality of water, and this is one of our top priorities. And application of renewable energy is what we are putting efforts into. Outside and inside the plant, we are putting effort to make the appearance good. I'm sure you will see this today. From the bus, you will see the scenery in the campus, which you will enjoy. That concludes my presentation. Thank you for your attention.
Thank you very much. That was Mr. Kikuchi. So with this, that completes the presentation on the Nissan Intelligent Factory initiative. Thank you for your kind attention, and thank you for listening to our presentation.